Alkenes. Alkenes have at least one double bond between two carbon atoms. Due to their double bond, they are unsaturated. Their general formula is CnH2n, where N is the number of carbon atoms and 2N is the number of hydrogen atoms. The names of alkenes use the ending -ene. The simplest alkenes are ethene, which comes from the two-carbon parent ethane, and here's our double bond right here, and then propene from the three-carbon parent propane. And here's our double bond here, and it's also on the ball and stick model as shown there. Here are the first 5 alkenes and the general formula for any alkene right here, CnH2n. So let's just look at butane, for example. We have 4 carbons and we have to have 2n hydrogens, so 2 times 4 is 8. And you write that as C4H8. And here's a little practice for writing alkenes. Complete the table for the next 4 alkenes and check your answers on the next slide. So feel free to pause the video now, do the work, and then move on to the next slide. And here's our formula for creating an alkene. Well, hopefully you got this. Basically, you're just taking the number of carbons and doubling it to find the number of hydrogens. So C7H14, and then here C10H20 for decene, and then the general formula is this. The physical properties of alkenes are similar to those of alkanes, probably because it's just one of the bonds we're turning from a single into a double. The first 3 members are gases. Alkenes with between 4 and 18 carbons are liquids, while those with more than 18 carbons are solids. They are less dense than water, just like the alkanes. And again, they're insoluble in water like alkanes, but soluble in organic solvents like benzene, ether, etc. They are weakly polar since some of the electrons, the pi electrons, and that'll be covered probably in the AP Chem course what a pi electron is, but just throwing a phrase out there. Those electrons in the double bond can be polarized, resulting in higher dipole moments than those of alkanes. Again, like alkanes, their boiling points increase with increasing numbers of carbon atoms. For each CH2 group added, the boiling point increases by 20 to 30 degrees Celsius. These values are comparable to that of alkanes with a corresponding carbon skeleton. The dipole moment and melting point depends on the groups on the double bonded carbon atoms. Alkenes are more reactive than alkanes due to their double bond, which acts as a highly active reactive electron center. The most important reactions involving alkenes are addition, which is called bromination, reduction, hydrogenation, and oxidation, combustion or the addition of water, which is hydration, or finally polymerization. And put a check mark there too. Ethene, which is also called ethylene, that's probably the more common name, is used for artificial fruit ripening and seed germination. This way they can send fruit when it's not ripe through some kind of transportation system, and when it gets to the end customer, then they can hit it with the ethene to make it ripen and look more attractive to purchase. Alkenes are used for the production of alcohols, and ethylene and propylene are widely used for polymer synthesis. In the prior slide, we used these 2 names for the same compound, ethene and ethylene. This is common in organic chemistry, as many compounds have a common or commercial name and also a scientific name from IUPAC, which is the International Union of Pure and Applied Chemistry. In that case, ethene is the IUPAC name and ethylene is the common name. This is similar to the common name of an animal being dog, while its scientific name is canine. In most cases, you will be provided both names if the common name is more recognizable.